About sine and cosine, we are going to graph the parent functions so you can see why they're waves, but we're going to save the rest of actual graphing for next week. On Monday and Tuesday, you guys have block scheduling, so I'll be seeing you on Tuesday. We're going to take the practice ACT during that time. We'll probably do a little bit of trig review as well that day. But we'll pick back up with graphing on Wednesday, and that's when we'll start graphing all different kinds of sines and cosines. Okay, to see why the graphs look the way they do, we're going to make a table of values. So we have like an x and a y, an input and an output. Our input is going to be the angle theta, and our output is going to be the sine value of that angle. And so I have behind here, I know you can't see very well, but it's just a unit circle. So if you want to look at your unit circle, you could follow around the sine values on your unit circle. Now I put in for theta, I only put in the quadrantal angles. That's enough points to really see like the best parts of this sine wave. But I'll talk about like you could use other angles too. So if I started at the angle 0, and I wanted the sine value, I'd be looking at the y coordinate, which is 0. So the sine value at 0 is 0. And then I'm going to move right up to my quadrantal angle. We know that this on the unit circle is the ordered pair 0, 1. So the sine value is 1. And I get to pi, I'm back to 0. 3 pi over 2, I'm at negative 1. And then 2 pi, that's really the same angle, right, as 0. So at this point, I'm like repeating myself. And I could make that table of values longer. I could go from 2 pi, I could go to 5 pi over 2. It's 2.5 pi, and I'd be back at 1. Then I could go to 3 pi, I'd be back at 0. And I could go to 3.5 pi, or 7 pi over 2, and I'd be back at negative 1. 4 pi. And don't you agree, like, we can just keep going around and we're stuck on this circle and we're just going to keep getting the same values over and over again. Now, if you wanted to, you could throw in some other values, like maybe you want to do like a pi over 4. You know, you could do pi over 3, pi over 4, pi over 6. You could get a whole bunch of points. Well, the sine value at pi over 4 is square root 2 over 2. You know, for graphing purposes, that comes out to about 0.7, so a little bit less than 1. And what you'll find is if you do any of those other ratios in the quadrants, they're always going to be less than 1, but greater than negative 1, so they're stuck in between. All right, if I plot these points that I have in my table, notice my horizontal axis is my theta, and my vertical axis are my outputs, my sine values. So I would do 0, 0, pi halves 1, pi 0, 3 pi halves negative 1, and 2 pi 0. And you know, like I had done that pi over 4, that'd be directly in between 0 and pi halves. That was like 0.7. Somewhere right there. I could fill in other ones if I wanted to. I'm not going to take the time to do that. This is creating that wave shape. So when we connect these, we're not going to connect them with straight lines. They're going to be curves. So it comes up like a mountain. Turns around. And really, those aren't even just starting and stopping points. That just continues, right? So like if I were to go around the circle again, I get another mountain and then a low point. And another mountain and then a low point. And it just continues on as you go around and around the circle. Well, we can do the same thing for cosine. Now, as you're working and filling out cosine and kind of organizing your notes, if you're doing the graphs on the little graph sheets I gave you, you can go ahead and tape them in and then pass the tape to the other groups that don't have tape. So you should be able to, I'm just doing the quadrantal angles here, you should be able to go around the unit circle and pick out their cosines. This time, instead of looking at the y coordinate, you'll look at the x coordinate. What do I get? 1, 0, negative 1, 0, 1. Okay, now the most important thing when you get to the point when you're drawing cosine, the most important thing I can tell you is do not make it look like a V, like straight lines. It's not a V. It's really got the same shape as sine, right? We're only just seeing part of it. So remember that right before we get to this 0, 1 point, we must be coming up. And then we're turning. And this is my turn point. So make it look like it's a wave, not straight lines. And give it some curve. Now, we usually only have you graph one period, so you really only see like that particular shape. But just know, it's just like copy and paste right next to it, right? So that it's a continuous wave. It continues on forever. And we'll get into domain and range next week, but you can probably look at these graphs and see, since the arrows are pointing left and right, domain is all real numbers, but because of the nature of the wave, it has a min and max point, so its range is -1 to 1 for the paragraph. This is really all of the actual graphing that you're going to do today. Your homework, you shouldn't have to graph any of the trig functions. You won't be graphing until next week. Now I have just 2 more really quick visuals that I'll show you just to make the connection between the unit circle and the graph. So on the left here you can see there's the triangles going around the unit circle forming the bow tie or the butterfly shape. And we're tracking the red line, which is the y coordinate, like how high we're going up or down. So when it starts here in the first quadrant, it's positive. That's this little section right here. And it peaks at pi over 2. That's when it gets to its highest point 1. In quadrant 2, y is still positive, but now it's decreasing as it approaches the value at 0, the value of 0 at pi. So here's quadrant 1, quadrant 2. Notice they're both above the x-axis because sine is positive. And then we get quadrant 3 and quadrant 4, where that part is that valley of sine, because it sits below, it's negative in quadrant 3 and quadrant 4. So you can kind of see that connection between the quadrants. And then you could see the same thing if you wanted to look at it with a cosine function. Notice that this time, every time it starts, it's starting out on the right side of the circle, so that's the furthest positive it'll ever be for cosine because we're looking at x-coordinate. So it starts at 1, it gets closer to 0, so we're approaching in quadrant 1 the x-axis. In quadrant 2 and quadrant 3, we dip below the axis, the x-axis, because cosine is negative in those quadrants, and only in quadrant 4 do we come out of that to the positives. And it would just keep repeating, right? Okay. So, there's a couple of vocab that you need to write down. I'm going to give you some time to write it down, and then I'll talk about it. there's two things we're going to talk about when we talk about sine and cosine graphs. Those are amplitude and periods. All trig functions have periods, only sine and cosine have amplitudes. Because only sine and cosine have mins and maxes within a wave. So the most important thing that I can tell you about amplitude, if you were going to like highlight something, is to remember that amplitude is only half of the distance from min to the max. Most common mistake I see people make when they are using amplitude is they treat amplitude like the whole distance from min to max, okay, but it's only half the distance. So I'm going to draw a picture. I'll draw a sine graph. So sine always starts at 0, 0, the parent graph, and then I always say mountain high, valley low. That's how I draw my sine graph, I remember. I'll talk more about that on Wednesday. But when I'm talking about amplitude, so it's half the distance from the min to the max, so there's always like a midline of your graph, like a middle, where it sort of is the same on both, and then half of that is an amplitude. So really to make a graph, we're going to see on Wednesday, we're going to actually have to use two amplitudes. So the height of the graph is twice what the amplitude is because the amplitude is only half the distance. Period represents the horizontal distance where we complete, I don't know why these words got all squished together. Sorry about that. A point on the graph and the point where the graph begins to repeat itself. So remember, this parent graph that I'm showing you, it has quadrant 1, quadrant 2, quadrant 3, quadrant 4. And then once we get past this, we're just repeating that same shape, mountain high, valley low, just copy and pasting it. So this right here is one period. And then after that one period, then I repeat. I have another period, okay, where I just repeat the same thing. Now we're going to see in a little bit where we can change the period. So like the parent graph's period is 2 pi. We can change the period so that it's more or less than 2 pi. And when I'm doing that, I always think about a slinky. So if I stretch out the slinky, the waves are long. And if I push the slinky in, the waves are really fast, right? So that can happen with a trig graph. If we don't stretch out the period, its normal period for sine and cosine is 2 pi, because you got to go all the way around the unit circle before it repeats. Okay, so now I'm going to give you an opportunity to write down some stuff about the functions. Move it up just a little bit. Okay, so in these general forms, notice that we're putting in these letters A, B, C, and D. They act very similarly to A, H, and K that we use with other functions. Why the textbooks always change to A, B, C, D for trig functions, I'll never know. I actually like that they have the fourth letter here because now you have like something to multiply on the outside and something if you multiply on the inside, right? The A and the B. Or before we just had A, but it was like if it was outside we knew it was vertical stretch and shrink. If it was inside we knew it was horizontal stretch and shrink. This kind of makes it a little bit easier. We're going to talk about in context with those characteristics though that we had said previously. So amplitude is the absolute value of A. That means that amplitude, when you write that down for me, it should always be what? Positive, because it represents a distance, and distance is always positive. So we should always write down positive amplitudes. If your A is negative, that's just going to be a reflection of that wave, right? So if you're reflecting the sign instead of mountain high, valley low, it's going to be valley low, mountain high. The period is affected by horizontal stretch or shrink, which is going to be your B value. And for sine and cosine and their reciprocals, their periods will always be 2 pi over B. That will change for tangent and cotangent. They have a shorter period. We'll talk about that next week when we get to those graphs. But for sine, cosine, and their reciprocals, always 2 pi over B. Now, horizontal and vertical shifts, you can do separately, C over B. So that's going to be like a horizontal left or right, and then your vertical shift up or down, D. But we're actually going to report them together as the starting point for the frame. Now, you don't really know what I mean yet if we haven't done graphing of trig functions, like what I mean by starting point of the frame. But it's just an easier way to make the graph. So we're going to use the framing method, but I'll talk more about that on Wednesday. Right now we're going to practice, can we find that start point? What's the left-right shift of this picture? Okay, and up-down. One thing that some people will benefit from writing in their notes for horizontal shift or starting point I used to say it all the time about H, and now I'm going to say it about C. C looks like the opposite of what it is. If you look at the two general forms at the top of the screen, C is the only variable or only parameter letter that has a negative in front of it. So every time you put a number in, it looks different than what it really is. So remember, when you're pulling out C from an equation, it'll look like the opposite of what it really is. Okay, let's do some practice. So this is what you're going to be doing on your homework. It's going to be not too bad. Identify your amplitude, period, and starting point. And then we're going to make note if the graph is reflected. One thing that may be helpful is to label whether these are A, B, C, or D. I usually like to just try to write the general form above it. So this must be A times the sine of BX. It doesn't look like I have any C's or D's. Things are being added or subtracted. So that means the value of C and D is 0, which will end up working really nicely in our starting point. So amplitude is the absolute value of 4, which is just 4. Period is 2 pi over B, which looks like B is 6, so I should always simplify that, pi over 3. And my starting point is my C over B comma D, but since C and D are both 0, this is just going to be 0, 0. So the starting point for our frame will be at the origin. When our period is pi over 3, that means it used to take 2 pi for us to do a whole sine. Now we're going to squish that into pi over 3. So we're going to go valley high, mountain low in just pi over 3 units instead of 2 pi. So if we're thinking about a slinky, we're squishing the slinky, so the waves are happening really fast. You try this one. y equals negative 2 cosine pi x. I put my answers on the board. How'd you do? Should make a note that it reflects in the x-axis because of the negative out front. The amplitude, make sure you didn't put negative 2. It's got to be a positive 2. Some of you may not write down the absolute value. I'm just writing that for notes purposes, how we got our answer. Period. On this one, interestingly, if b is pi, then 2 pi over pi is just 2, right? So you can have periods that don't have pi in it, just like it just represents now a decimal radian, 2. So think about like normally cosine would happen, it would have a period of 2 pi, which is like 6.28. Now we want to get in a whole cosine in just 2 units, so that's like a third of what it was before. And then starting point at 0, 0. Anybody got any questions for me? Let's try some with C's and D's, right? Some interesting starting points. Okay, so same directions, just a new function. Y equals 1 minus 3 sine of x plus pi. Now you might want to take time on this one to figure out which numbers represent which parameters. So like we have a sine, and then of course this must be bx minus c, so what's the value of b in this one? B must be 1, because there's 1x right there. These other two numbers, a, remember, is always the thing that's getting multiplied in front of a sine or a cosine, so that must mean that negative 3 is a. Therefore, that 1 is actually d. It's really just d plus. So you could have a plus d on the back, or you could have a d plus in the front. It's the same thing. If you just have some random number being added or subtracted with your sine or cosine, that's your d value. So of course I've got negative a, that means there's a reflect in the x-axis. My amplitude is the absolute value of negative 3, which is 3. My period would be 2 pi over 1, which is just 2 pi. So anytime b is 1, your graph has the same period as the parent graph, 2 pi. It just takes a full circle, full revolution. And then for this one, our starting point, okay, what's the value of c? What's that? Negative pi. Be careful. It looks like plus pi. It looks like the opposite. So the c is negative pi. Our b was 1. And then our d is also positive 1. So that would be negative pi, 1. That's my starting point. It just means go left pi and then up 1. And then we'll have a new frame for our graph. I'm going to give one for you to try with the C and D values. And I did put in some fractions. I know how much you love. So think about how would you work with it as a fraction. See if we can get the answers. I'll put my answers up here in just a little bit. How's this for your period? 4 pi? If you take 2 pi divided by 1/2, you're really multiplying by 2, so it actually gets larger. That means our slinky is getting stretched out. It's taking longer for a wave to make a full period or cycle. When you do your starting point, remember your starting point is going to be C over B comma D. Your C should have been positive pi over 4. Your B, of course, is 1/2. And then your D is 2. That's pi over 4 times 2. 2 over 4 is 1/2. So your starting point would be 1/2 pi or pi halves comma 2. So that's what we should practice on your homework is, can you do amplitude, can you do period, can you do starting point, whatever the directions are in the textbook. I don't know if they're the same for all of the problems, but ignore whatever directions the textbook has. This is what I want you to do for practice. I'll come back to this note later because it's going to be so long till we do it. So this is your homework assignment on the gold sheet. So state the amplitude, the period, and the starting point, and then also, of course, make note if your graph gets reflected.